In this lecture, we are going to talk about other flags and other condition-based jumps or other kind of conditions. We don't need the first 4 lines in here, so we just cut them, or actually let me just say jump not A in here. In this way, this wouldn't jump to the printing label in here, because jump not A means the opposite of jump A, and it means jump if not greater, therefore it wouldn't jump to the printing. What we are going to talk about, well, we want to check all the 3 ways of comparing. If the first one is bigger than 1, if it is equal to the second one, or if it is smaller. So in here we want to make the R10 register to be equal to R9. We have a couple of options, one of them being sub R10 and 4, but I want to use the move in here to say move R10 and 2, so that the R10 value, which is 6, would be overwritten by 2. Even though R9 register would be kept 2 because of this instruction, I just want to repeat the instruction so that we would have all the codes in separate blocks. And then we want to compare the R10 and R9. Well, because both of them are equal, and we explained in the previous lectures, the 0 flag, the third bit from the right in the R flags register, would be set. And there are a couple of jumps based on these conditions. One of them is JZ. If we say JZ printing, what this jump does is that it looks at the Z flag in the third bit. If it is set or equal to 1, then the jump would happen, and this jump would make the RIP register to be equal to the printing address in here. We used the J and Z for loops in the previous lecture, and we wanted it to stop. So therefore you understand, JZ and J and Z are the opposite of each other. JZ would jump only if the 0 flag is set, which means that the 2 operands getting compared to each other are equal. We have also another jump which I want to give it to you after we have run this program once. So I press Ctrl O and hit enter and exit in here. Let us assemble it and link it, and then we just execute it. Hit enter, and as you see, it has been executed. If you want to make sure if the jumping is because of JZ and not J and A, we could just copy these lines. Let me just cut them in here, save it, exit, assemble it, link it, and execute it. As you see, we have hello world in here. So let me just paste the lines again so that you would have them. And also the other one that I wanted to show you instead of JZ is JE. This means jump if equal, as the E suggests. So somehow the JZ and JE, they have the same meaning. So in here I press Ctrl O and hit enter and exit, again assemble it, link it, and execute it, and we have hello world printed on the screen. Let me also check it using the GDB debugger. So in here I say GDB compare and hit enter. So we would want to just break at a start, run it, and right now if I say info registers RIP and also dump the assembly in here, we are at 4000 CB, which means this address in here. We want to also, if I look at the eflags register, none of them are set, so we step through the program. 1 time 2, we are at 4000 D7, which means that the compare has happened, the first compare actually. Right now if we look, none of them have been set. You see the eflags, nothing has been set, therefore we won't jump. So step I, and the next one would be 4000 DC, which is after that, making the R10 register being equal to 2. If we step I again and say info registers R10, you see that we have the value 2, even though the value of 9, the content of 9 is equal to 2, but we just execute the other instruction and it is still 2. Now the RIP register so let me go to RIP register is equal to 4000 E8, which is comparing R10 and R9. So again, look what happens. One more time, let me show you eflags. It's just none of them is set. Now a step I, and now look at the eflags. You see the Z flag has been set and also the parity flag has been set. The reason for both of them is because the last instruction was 2 minus 2. We said compare just does the subtraction. 2 minus 2 is equal to 0, which the binary value would be just, well, 0. We won't have any set bit in the binary representation of 1, which is, well, an even number. Therefore the parity flag would be set. The 0 flag also is set. Therefore we would jump. Let me make sure of that by showing this to you. Well, we copy it, we go to the Python interpreter, and let me just paste it and hit enter. From right to left, the third bit is 0 flag, which is set. Then the 4th, 5th, 6th, and 7th bit, which is parity flag, is also set. Now it's time to jump. Right now the RIP register is pointing to 4000 EB. 4000 EB is jump. If equal, well, it is equal, so we would jump. Step I, and now look at the RIP register. It points to 4000 B0, which is actually in here. So these instructions would be executed and we would have printing the hello world one time on the screen, and this would go on and on until we have a complete loop.